So good morning everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor Hampel Kleeman. And if you are new to this channel, consider subscribing, hitting the like button, and also don't forget to share. And of course, if you want to join personal tuitions, you want to register at Hampel Kleeman Online Academy, make sure that you inbox me on the WhatsApp line which has been projected on the screen. We have been given interesting questions, and the first question is saying we prove that the following expressions are irrational numbers. Okay, so in order to prove irrational numbers, there is a concept that we use. Okay, there is a concept that we use, and the concept is proof by contradiction method. So it's a proof by contradiction method. What does this imply? In order for us to prove that a root of 3 is an irrational number, then we will need to say that we make an assumption that root of 3 is actually rational. So if that is going to be true, then this is just the same as root of 3 is going to equal to a over b, where a and b are what we call coprimes, or numbers that are only divisible by 1 and themselves, coprimes, and that b cannot equal 0, because if b is equal to 0, the function is going to be undefined. Okay, because if b is equal to 0, okay, the function is going to be undefined, Okay, if we make this assumption, then we can say that this guy can be put in brackets and the other end in brackets. Then we are going to get something like 3 is equal to a power 2 over b power 2. Then we can cross multiply. We are going to get 3. Okay, we are going to get 3b power 2 equal to a to the power 2. Then we can say over 3 over 3. Okay. Then our b is going to equal to a power 2 over 3. Now notice that whenever we are dividing 3 into a to the power 2, we are getting b. Okay? We are getting b. Henceforth, a is divisible. A to the power 2 is divisible by 3. And if this is true, then it implies that even a is going to be divisible by 3. Why? Because when we divide 3 into a to the power 2, we are getting b to the power 2. Okay? So that is the concept behind. Now, if this is true, then it implies that a can be equal to some integer 3k, where k is going to be a member of positive integers, okay, or just integers like that. Okay, if that is true, then we can say b to the power 2 is equal to, where there is a, I'm going to replace with 3k. Notice what is going to happen. I want you to observe what is going to happen. Then over 3. Then this is just the same as b to the power 2 is equal to, this will be 9k power 2 over 3. Okay, then this is just the same as b power 2 is equal to 3k power 2. So over 3 over 3. So k is going to equal to b power 2 over 3. Now notice what is happening. Okay, notice what is happening. When we divide 3 into b to the power 2, we are getting a significant number. We are getting a defined number. Okay, henceforth, we can say that b squared is also divisible by 3, And if this is true, then b is also divisible by 3. Okay, it is also divisible by 3. Now, if this is true, then it means that we can, it means that we are able to divide 3 into b, and at the same time, we are able to divide it into a. Okay, but we mentioned that in the statement, we mentioned that A and B are co-primes, meaning there should only be one number that should be able to, two numbers that should be able to be divided by these numbers. That is 1 and the number itself. But in this case, even 3 is able to be divided. Okay? Henceforth, our assumption, okay, that henceforth, this is going to be the conclusion. The conclusion is very, very important. Okay? The conclusion is very important. Let me put it here. Okay? Henceforth, our assumption, okay, our assumption that root of 3 is equal to A over B, where A and B are co-primes, is false, because 3 is able to get into those numbers. Is false. Henceforth, root of 3 is not rational. Instead, it is irrational. So that is how you prove for this particular type of questions. Okay, they are actually very simple. That is how you prove your first question. Let's go to the second question. The second question, which happens to be B, is simply saying 3 plus 2, then the root of 5. We prove that this is irrational. We use proof by contradiction method, where we say, let 3 plus the root of 5 be rational. We contradict that it is not irrational. Instead, let it be rational. If that is going to be true, then 3 plus root of 5 is going to equal to A over B. Now, we can collect the like terms, so we're going to remain with 2, the root of 5, then this guy can go on the other end, so it's going to be A over B minus 3. Okay, so this is going to be B as our common denominator, then B into B is 1, so it's going to be A there, minus 1 into B is going to be 3B. Okay, so this is just what we have there. Then we can say over 2, even here over 2, then we cancel. Then we're going to get square root of 5 is equal to A minus 3B over 2B. Okay, now I want you to notice something here. I want you to notice something which is very, very important, okay, on this particular question. Something which is very important on this particular question. Notice that, okay, notice that what we have here, we have A and B, okay, being integers, okay, being integers, okay. So let's say A and B are integers, okay, integers being, so make sure that you have a solid conclusion, being expressed in the form A over B, okay, where B is equal to, where B is not equal to 0, okay. But we mentioned that we mentioned that 3 plus 2 root 5, okay, 2 3 plus 2 root 5 is equal to A over B, where A and B are coprimes, right? We mentioned that, right? Then, in the actual sense, we know that this side here, this part here, is irrational, okay? We just made an assumption, but we know that this part is irrational. And at the same time, on the other end, what we are getting, this statement here that I made here, implies that these are rational numbers. Why? Because they are able to be expressed in the form A over B, like this part here, okay? But we know that 3 plus 2, the square root of 5, equal to A over B plus A and B, where A and B are coprimes. We know that this statement was supposed to be giving us a rational assumption. So imagine this side we've got irrational, and then on the other end we've got rational. Henceforth, this thing is not holding, okay? So when you establish this particular theory, you understand that actually root of 3 plus the root of 5 is irrational. Okay? It is irrational. So make sure that you pay attention to your contradiction and what you're going to get at the end. Okay, let's try to do another question. Okay, the other question is going to be C. So C is 1 plus the root of 2. So we use proof by contradiction method, where we're going to say we let 1 plus, remember we know that this is irrational, but in order to prove that it is irrational, we let 1 plus the root of 2 be rational. Then we can say that if that is irrational, then we can say that 1 plus the root of 2 can equal to A over B. Then we're going to have root of 2 is equal to A over B minus 1. So this is going to be B. B into that is going to be A minus B. The same thing now here also. You're going to have root of 2 equal to A minus B over B. Okay? Now, how do you come up with your conclusion? Okay? How do you come up with your conclusion? If A and B are integers, okay? If A and B are integers, okay, where B is not equal to 0, okay, and they are expressed in the form A over B, then A and B are rational. True. That is very true. But root of 2 is irrational. Henceforth, this is not true. So the assumption that the root of 2 is equal to A minus B over B is false. Okay? Henceforth, root of 2 is irrational. That is the concept behind these particular questions. They're actually very simple. Just understand what you are doing. We have another interesting question. D, they are saying root of 3 plus root of 2. We prove that this is irrational. So we can say that we let root of 3 plus root of 2 be rational. So we have contradicted If this is true, then it implies that the root of 3 plus root of 2 is going to equal to a over b, where a and b are co-primes and that b must not equal 0. Now, you need to know how to multiply this because you're going to say to the power 2, even this side to the power 2. So this is just the same as root of 3 plus root of 2 multiplied by root of 3 plus root of 2 equal to a squared over b squared. Now, how do you multiply this? This part multiplied by that part. If you know how to multiply sets, you understand that root 3 multiplied by root 3 is going to give you 3. We just cancel the roots. Then root 3 multiplied by root 2 is going to give you something like 2 multiplied by 3 inside. Okay, then you say plus root 2 multiplied by root 3, it will give you 2 multiplied by 3. You just multiply what is inside and you maintain the root. Plus root 2 multiplied by root 2, it will give you it will give you a 3. You just remove the bracket if there was the root. Okay, you remove the root. So that will give you a 2 equal to a over b power 2 power 2. Notice that you are going to get something like 3 plus 6 plus 6 plus 2 equal to a power 2 over b power 2. So what is this and that? What is root 6 plus root 6? Those are like terms. So it will give you, why am I even trying to delay? So let me do this. Okay, so we can add the like terms. 3 plus 2, it will give us 5. Plus root of 6 plus root of 6, it will give us 2 root 6 equal to a power 2 over b power 2. Now let's do our thing. This expression given can also be written as 2. And then we have root 6 equal to a power 2. Okay, a power 2 over b power 2 minus 5 over 1. So this is going to be b to the power 2. Then we're going to have a power 2 there. Then we're going to have 5 b power 2. Okay, and that is going to be 2 root 6 equal to that. Then we can divide by 2, even here by 2. You're going to have the square root of 6 equal to a power 2 minus b power 2 over 2b. Now notice this is just the same concept we are using here. This is just the same concept we are using here. If, what is the conclusion? If a and b are integers and they are expressed in the form a over b, like this part, this is a over b, then a and b are rational, right? They are rational. But square root of 6 is irrational. Yes, square root of 6 is irrational. So we've got something that is irrational here and something that is rational on the other end. Henceforth, root of 6, sorry, henceforth, root 3 plus root 2 is irrational. The concept is the same and very simple to understand. Okay, so this is actually very simple. Let's try to do another question. So this is actually very simple to understand. Just ensure that you get the concept. The other question E is 1 over the root of 2. So for this one, how do you prove? Okay, we can let 1 over root of 2 be rational. The same concept. Then if this is true, then it means that 1 over root 2 is equal to A over B. Now, if you are familiar with sets, you've watched some of the videos that I've made on sets, you know that there's a way to manipulate this, and the way to manipulate it is to multiply it by 2. Even here by 2. So if you multiply that, you're going to get something like 2, and then that and that will go, because root 2 multiplied by root 2, you just cancel the power and maintain the number. So this is just the same as A over B. Okay, so when we reach here, what are we supposed to do? We can cross multiply. So if you cross multiply, you're going to get something like B root 2 is equal to 2A. Then over B, you're going to get root 2 is equal to 2A over B. That and that. Okay, before we even go any further, we had root 2 is equal to, okay, this was supposed to be, okay, we had something like 2A over B. Okay, let me just conclude it from here. There's no need to go any further. Okay? No need to go any further from here. If A and B are integers expressed in the form A over B, then A and B are rational. This part here is rational because it is expressed in the form A over B. But root of 2 is irrational. What does this imply? It implies that the assumption that 1 over root 2 is equal to A over B, where A and B are coprimes, and that B is not equal to 0 is false. Henceforth, root of 2 is irrational. That is how you solve proof by contradiction method. How about if you have been given a question like this one? F, where they're saying 1 over 1 plus 2. Okay, prove that this is irrational. So you're going to say we let 1 over 1 plus the root of 2 be rational. If this is true, then 1 over the root of 2 is going to is going to equal A over B, where B and A are co-primes, and that B must not equal 0. Now, let's try to work out this first. So I'm going to show you how to work out this. Whenever you're dealing with sets, you need to cancel the denominator. You need to put the denominator in a whole number, not a set. How do you do that? Just change the sign here. You multiply everywhere by that. 1 multiplied by that, you're going to get 1 minus root of 2 over 1 multiplied by 1, it is 1. 1 multiplied by negative root 2, it will be negative root 2. Positive 2, positive root 2 multiplied by 1, it will be positive root 2. Positive root 2 multiplied by negative root 2, it will be negative 2. So we're going to get 1 minus root of 2 over 1 minus 2. So this is just going to be the same as 1 minus root 2 over negative 1, which can also be written as root 2 minus 1. So this is just the same as root 2 minus 1 is equal to a over b. Then root 2 is equal to a plus 1 over b, which is just the same as b, then a plus b. Same concept. If a and b are integers, and a and b are expressed in the form a over b, then a and b are rational. But root of 2 is irrational. Hence, the assumption that 1 over 1 plus the root of 2 is actually false. You can write this statement somewhere, not there, I've written it somewhere to make sure you correct your work. If that is the theory behind, then we can conclude that 1 plus root of 2 by contradiction method is actually irrational. That is how you solve this particular question. To prove to me that you have understood, I'm going to give you this question. Prove that 2 plus 5 root 3 and 5 root 6 are irrational numbers by contradiction method. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share to others. Thank you so much.